All right, so I just wanted to show you what a graph of this polynomial function looks like. So here's the graph, and I'll explain to you the zeros and the multiplicities based on the graph. All right, so again, remember zeros happen where our function is 0. So that's where we cross the x-axis. And so here we touch the x-axis at -3 as well as 7. But at -3, our graph goes all the way through that point. However, at 7, we just touch the 0 and turn back around. And that's exactly what happens. So whenever we have an even multiplicity, this is what it's going to do. It's going to touch, turn back around. And when we have an odd multiplicity, it's going to go straight through the x-axis. It's going to cross it. All right, so let's look at another example. Same instructions, find the zeros, determine the multiplicity of those zeros. All right, so we got to set the function equal to 0. This one is not factored for us, so we have to do the factoring on our own. All right, I can factor out an x. All right, we got a quadratic in there. We can factor that. Looks like both -3. Oh, I have the same term twice, so I can write that as a square. And that's going to tell me the multiplicity of my 0 that I'm going to get there. Okay, so we have two things multiplied by each other that equal 0. That means at least one of them equals 0. So 0 equals x. 0 is x minus 3 squared. So 0 is x. And over here, x is 3. So here are our two zeros. X equals 0 and x equals 3. Okay. All right, so now let's look at each one of those zeros separately and determine the multiplicity. All right, so at x equals 0, all right, we just have this x term once. So that means the multiplicity is 1. It's odd. So that means at x equals 0, our graph is going to cross the x-axis. All right, and then our other 0 was at x equals 3. And the multiplicity of that, well, that occurred twice here. So the multiplicity is 2, which is an even number. So that means our graph is going to touch the x-axis and then turn around at x equals 3. All right, so this is also something we're going to use to help us draw the graph of our polynomial functions. All right, let's do one more thing before we get to drawing that graph. Intermediate value theorem. So this is a theorem that comes up in calculus as well, but this time we won't use calculus. So the intermediate value theorem says that let f be a polynomial function for a less than b if f of a and f of b have opposite signs, then f has at least one 0 in the interval between a and b. So I'll talk about how this works with this example. So number 3 says use the intermediate value theorem to determine if this polynomial has a real 0, so where our graph equals 0, on the interval between -1 to 0. And so the reason we may want to use intermediate value theorem instead of just setting this equal to 0, this is not that easy to solve, right? But maybe we can just determine if there's going to be a 0 in the interval. Okay, so all we have to do is plug in the endpoints, so f of -1 and also f of 0. So we had to find both of those values. So we're plugging in -1 here. Okay, and so I get -2. And then here I'm going to plug in 0. So I get +2. All right, so what do we know about -2 and +2? They have opposite signs. So that's what I'm going to write next. -2 and +2 have opposite signs. All right, so if we're looking at our y-axis, -2 is down here, +2 is up here. That means we have to cross the x-axis to get between them. So that means our answer is yes, our function has a real 0 on that interval. Okay. All right, so now we get to the final thing that we've been building up to. We're going to sketch, it won't be perfect, but we're going to sketch a graph of our polynomial function. All right, so I have 4 steps to do this. So the first, we're just going to build on everything we've been doing today. The first step is to look at the leading term to figure out the end behavior of our graph. So are we going to go up to infinity, down to -infinity? What's going to happen? All right, so to do that, we need to know what's our leading power, or the degree of our polynomial. So for this one, the highest power we have is 3, and that's an odd number. Okay. All right, and then let's look at the coefficient. It's 1. The coefficient for x to the third is 1, and that's a positive number. All right, well, what does that mean? Maybe we have to check back to our leading coefficient test, right? We have an odd leading power, so we know it's going in opposite directions, all right? And then our number was positive, so that means it's going to fall left and rise right. All right, so what does that tell us? So when we're on the left side of our graph, so as x goes to -infinity, that's the left side, our function is falling, so it's also going to -infinity. And on the right side of our graph, that's where x gets closer and closer to +infinity. If we're going to rise, our function gets bigger, so it's going to go to +infinity. So that's the first thing we care about, is our end behavior. The second thing we care about is the y-intercept. Intercepts are still important. Do we remember how to find y-intercepts? So that's where we set x equal to 0. Okay, so we just need to find f of 0. So our x-intercept is going to be the point 0, 0. That was easy enough. Step 3, let's find the zeros, also known as x-intercepts. How do we do that? Well, we set our function equal to 0. And I'm going to factor this out. I can take out an x. Got x squared minus 9. Does anyone recognize that we have 2 squares, x squared, and 9 is 3 squared? This is difference of squares. We can use our difference of squares formula, x plus 3. Whoops, let me fix this. X plus 3, x minus 3. And so when we set each of these equal to 0, we get x is 0, x is -3, and x is +3. All right, and we also want to figure out the y values that go with those, so we get our intercepts, right? Which we know y is 0, right? So we have 0, 0, -3, 0, and 3, 0. Those are all of the zeros of our graph. Okay, I'm just gonna keep going with this video and just get it all done, even though we're going a little over 10 minutes. All right, finally, now that we have these x values, we just have to figure out what are the multiplicities of these x values we found. All right, so let's start with 0. At x equals 0, what's the multiplicity there? Well, we get it from this value here, this x. It only occurs once, so the multiplicity is 1, which is an odd number. So that tells us that our graph is going to cross the x-axis at x equals 0. All right, let's look at the next one, x equals -3. How many ways can we get that? Well, only from this factor. It's only here once. So it has multiplicity 1, which is an odd number, which means we're going to cross the x-axis at x equals -3 as well. And then finally, x equals 3. That also has multiplicity 1, which is an odd number, which tells us we're going to cross the x-axis again. All right, and so then our final step, now that we have all of the background information, we can sketch our little graph. So we want to plot our points and draw our end behavior. All right, so this graph won't be perfect, and you'll see why. So I'm going to draw my axes, label them. All right, and then I'm going to plot all the points that I found, right? We have this point at 0, 0. We have one at -3, 0. And we have one at 3, 0. Okay, so now my next step is to look at what I've learned about the end behavior. All right, so as my x values go to -infinity, so on this side, my function is going to go down to -infinity as well. So that means this is just going to go down forever. Okay. On the right side, as x goes to infinity, our function is going to go up forever. So we got our end behaviors. Now we just have to figure out what's happening at our zeros. Are we going to cross the x-axis, or are we going to touch it and turn around? Well, at 0, we're going to cross the x-axis. At -1, -3, we're going to cross, as well as +3. So that means this is going to go through the x-axis. All right, but somehow it has to get back down here. So this is where this is a sketch. It's not exact. There's a turning point that happens. All right, also at 0, we have to cross. So that means another turning point has to happen. And so this is kind of just a sketch of what that graph would look like. And so we call these turning points. And so if you wanted your graph to be a little more exact, you could plot some points. But I just care about a sketch right now. I want the end behaviors and what happens at these zeros here. So make sure that you're able to do all of the things from the learning outcomes. And if you have questions, make sure you ask me in class.